All right, so this is going to go through the, hopefully, in this one warm-up, we're reviewing all the different types, right? Because you have to do sine in order to get to cosecant. You have to do cosine to get to secant. And then tangent and cotangent. And I said it before, but I'll remind you again. Test-wise, you're going to get 3 graphs, 1 sine or cosine, and then whichever of those you get, you're going to get the other ones reciprocal. So you're forced to do both. So if you're getting sine, you're getting secant, because that makes you do cosine. If you're getting cosine, then you're getting cosecant, because that forces you to do the other. All right, so I'm going to start with tangent. Tangent of x plus pi. So with tangent, we identify A in the same way. It's what's in front. So A would be 1, which is still the amplitude. The B is what's attached to the x, which is 1. The period for tangent is pi over B. So this is going to be pi. And then tangent, cotangent gets different, right? For tangent, we take what's next to that tangent, which is here, and we set it equal to where tangent's undefined, which is at negative pi over 2 and at positive pi over 2. So I'm going to set x plus pi equal to negative pi over 2 and x plus pi equal to positive pi over 2. Solve by subtracting pi from both sides. So I get x equals, that would be negative pi over 2 minus 2 pi over 2, or negative 3 pi over 2. And then 2 pi over 2 subtracted from pi over 2 is negative pi over 2. And these are our center to asymptotes, right? So if I move from left to right, these are 2 and 3. And then from the one on the left, I do what? Subtract the period. So if the period is pi, from that one I'm going to say x equals negative pi over 2 minus pi. And to the one on the right, I add the period. So x equals negative pi over 2 plus pi. So this is 2 pi over 2. I get x equals negative 5 pi over 2. And this is 2 pi over 2. And I get x equals positive pi over 2. So there's, from left to right, my first and my last asymptotes. So the question on the test is going to give you a line. It's going to ask you to list all the asymptotes. Okay, remember these are lines, so you have to do at least one x equals. But if you do x equals and then negative 5 pi over 2, comma, negative 3 pi over 2, comma, negative pi over 2, and comma pi over 2, you don't have to write the x equals every time, but it has to be there at least once because you're identifying that these are lines. Good so far? Yes? And then goes to your graph. So on my graph, I'm going to plot these asymptotes, and there's a lot of negatives this time. Negative 5 pi over 2, negative 3 pi over 2, negative pi over 2, and then positive pi over 2. And then those are your asymptotes. So you draw your vertical dashed lines through there. And then I need to find the point halfway between each asymptote. So halfway between negative 2.5 and negative 1.5 would be negative 2 pi. Halfway between negative 3.5 and negative 1/2 would be negative pi. Halfway between negative pi and negative pi over 2 and positive pi over 2 would be 0. These are your x-intercepts. And then you want to at least mark your 1/4 and your 3/4 so you know how far in to go on those. And the amplitude tells you how high up to go on those. So because my amplitude started with 1, that means that the quarter point, this is tangent, so it goes down, left, up, right. That means at the quarter point, I'm going down to negative 1. And at the 3/4 point, I'm going up to positive 1. Repeat it for all 3 sections and then graph your curves. And that's number 1. All right, now we'll do 2, cotangent. So start the same way. We're going to identify the amplitude, which is 1. We're going to do the period. B is now pi, so the period is 1 because it'd be pi over pi. And then what changes between cotangent and tangent is what? What do we change to set it equal to?
0.
Good. Instead of doing negative pi over 2 and positive pi over 2, I take this and I set it equal to 0. and I set it equal to pi. Solve and I get 0, solve and I get 1. From the one on the left, I'm going to subtract the period, so 0 minus 1 is negative 1. From the one on the right, I'm going to add the period 1 plus 1, which is 2. Now you got your 4 asymptotes, and then you graph them. So I'm going to come over here. I've got negative 1, 0, 1, 2. I want to draw my asymptotes through those spots. I want to locate, God bless you, the point halfway between. So this would be negative 1/2. This would be positive 1/2. This would be 3 over 2 or 1.5. And then the amplitude here again was 1. Cotangent goes up, left, down, right. So a quarter of the way in, I'm going up to positive 1. And then 3/4 of the way into negative 1, a quarter of the way in up, 3/4 of the way in down, a quarter of the way in up, and 3/4 of the way in down. Yep.
When you have like a negative tan graph or like a negative tangent, is that the opposite?
The direction flips. So you don't switch where your asymptotes lie, but you will switch the direction.
Okay.
So the question is, like, if I had y equals tangent, let's say y equals tangent of x, and then I had y equals negative cotangent of x, are these exactly the same graphs? No. Do they both go up, right, down, left? Yes. But your asymptotes will be at different spots. Does that make sense? Okay. All right, then comes cosecant. All right, so y equals negative 2. Cosecant 4x means I first have to graph what?
Sine.
Good. So negative 2 sine 4x. My a is negative 2, which means this is going to be an upside down sign. But my amplitude is the absolute value of that, which is 2. The b is for the period for sine and cosine is 2 pi over b, which would be pi over 2. And then secant and cosecant, we go back to sine and cosine, which is the 1/4 point, the 3/4 points, the 1/4, 1/2, 3/4. So I'm going to take that pi over 2. I'm going to multiply it times 1/4, times 1/2, and times 3/4. I get pi over 8, pi over 4, 3 pi over 8. First one is 0, last one's the period, which is pi over 2. I would look to see if there's a phase shift. Is there a phase shift? No, I'm not adding or subtracting anything inside the parentheses, right? So I go straight to my graph.
Shouldn't the also be pi over 2?
Good? Yeah, okay. So then I'm going to plot 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. The amplitude is 2. And to get cosecant, I'm going to start by graphing sine. This was negative sine. So normally I start at 0 and go up. But if it's negative, I'm going in the opposite direction. So my graph looks like this. From there, everywhere there's an x-intercept gets an asymptote. But we said you need 4 asymptotes. Right now I only have 3. So you can either choose to extend it this way, and I don't need an exact point, but it should be spaced out evenly. Or I can extend it this way. Again, it doesn't matter. You only need one of these, okay? But it could be either of those. And then I draw my parabolas in that bounce off the max points opening up or the min points opening down. Is secant. So we're going to start by graphing cosine here. So I'm going to write it as y equals cosine x minus pi over 2. And then wherever the intercepts are is my asymptotes, and wherever the maximum, I bounce them off, right? So my a here is 1. My amplitude is 1. The b is 1, which means the period is 2 pi. This time there's a phase shift. So I set this equal to 0, and I get the phase shift as a positive pi over 2. Period's 2 pi. That's my standard period. So I already know those points. If I multiply by 1/4, 1/2, and 3/4, I get pi over 2, pi, 3 pi over 2. First one would have been 0, last one 2 pi. And then to each of these, I'm going to add my phase shift. So I'm adding pi over 2. So I get pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, and then this is 4 over 2, 5 pi over 2. So the first one's the phase shift, which makes sense. Okay, it's cosine, so we're going to start at the amplitude, which is 1, and then work our way down. So 1, 0, -1, 0, 1. That's my cosine curve. For cosine, I'm just going to drop down either side of it. Where it intersects the x-axis is my asymptotes. And then the parabolas bounce off the max and the min. So 4, 7 is inverse trig function. So we're going to apply the curve, but the good news is we kind of go back to the unit circle. So we're going to review a little bit of unit circle today because obviously that's on your test. Okay? So the entire idea behind 4, 7 or the inverse trig function is what would happen if I gave you the trig function and asked for the angle. So every answer here, for the most part, until we get to the very end, is an angle on your either unit circle or from your calculator. So I would give you, let's say, sine of an angle is 1/2. You would give me back what angle that is. That's the entire concept. Okay? Obviously, there's some catches along the way, but that's the big idea. So the first thing we have to do is look at the inverse sine function and restrict it. So the inverse sine function, which is either arc sine, that's one way of writing it, or sine -1, those are the same things, basically means that if I ask for the arc sine of something, you are giving me the angle that matches that sine. It is restricted from -1 to +1 on your x values and from -pi/2 to +pi/2 on your y values. And we'll talk about y in just a second. The domain is -1 to 1 because of the x values. And the range is -pi/2. This should be positive here to +pi/2. You will either see it written as arc sine or sine -1. Those mean exactly the same thing and they're interchangeable. And what I said at the beginning, the arc sine of x is the angle whose sine is x. So on your unit circle, these angles will always be your unit circle angles, okay? But outside of that, you can use your calculator, which is why it says or number, because sometimes it's going to have pi in it and sometimes it's not. But it will always be in radians, which means when you give me the answers from your unit circle, you're going to choose the radians one. And when you're using your calculator, you're going to make sure your calculator's in radians. So tests, you're going to have to flip back and forth because some of these are like this, and then some of them, like your word problems, right triangle trig, are often in degrees. So you want to make sure that you're comfortable flipping back and forth. All right, so if you think about, by now, hopefully we know the graph of sine pretty well. On the right-hand side is your sine curve. It's going to continue. So we normally graph one period, like from there to there. But the graph itself actually extends in both directions in an infinite pattern, okay? If you go back to inverses, so think back a couple of chapters into inverses, there was a test to see if something had inverse. So you remember inverse was where we took the x and the y, we switched them, right? And then solved for the new y. But before we could even do that, we had to see if something was 1-to-1, which meant it had an inverse. And that was the horizontal line test. So if your graph passes the horizontal line test, then your graph has an inverse, okay? Think about your standard sine graph, the one that's over here. If I took a horizontal line like that pink line that's there and I put it through it, is it going to pass my horizontal line test? No, it's going to fail it because it's going to hit that graph at more than 1 point. Does that make sense? So what you have to do to your graph is actually restrict it. And the way you restrict sine is what this little graph is. So we start it at negative pi over 2 and we stop it at positive pi over 2. So when I'm asking you for inverse sine values using your unit circle, your answers will only be from negative pi over 2 to positive pi over 2. And think about why that happens, okay? If I look at this graph, like let's say I just go from 0 and I go to 2 pi. I go to 0 to pi. If you overlap that on your unit circle, 0 to pi, what's true about all the sine, positive or negative signs in first quadrant and second quadrant? What would be all those y values? Would they be positive? Would they be negative? They would all be positive. We need something that's going to cover positives and negatives that's uninterrupted. So I can't say, okay, here it's positive and here it's negative. Let me look at those two quadrants. You need something that's uninterrupted, one fluid section of your of your curve. So we restrict sine to negative pi over 2 to a positive pi over 2. That way you get negative values and positive values. Does that make sense? So when you're answering these questions and you're using your unit circle, which I'll give you back on the day of the test, but you're going to want to add some stuff too. You will only use fourth quadrant and first quadrant for sine, and you will add the negative angles onto the fourth quadrant. So your answer should not be 7 pi over 4. It should be negative pi over 4. Which means if I don't give you a calculator, your answer is going to come from this little bank. It's going to go from negative pi over 2 to negative pi over 3, negative pi over 4, negative pi over 6, 0, pi over 6, pi over 4, pi over 3, and pi over 2. So the question will be one of these if we're talking inverse sine. And your answer is going to be what's above it. I don't need you to memorize this chart, okay? You're going to have your unit circle in front of you. You just need to know how to find your answer. Questions will look like this. Find the exact value of sine negative 1 of 0, arc sine negative 1, or sine negative 1 of negative pi root 3 over 2. So before we even get there, think about what you're going to have in front of you because you're going to have your unit circle, right? So your unit circle, which it's been a little while, but this was 0. This is pi over 6. This is pi over 4. This is pi over 3. This is pi over 2. And then these angles on your unit circle that you're given are going to say 11 pi over 6, 7 pi over 4, and 5 pi over 3. But for the inverse, you want to add on the negative angles. Negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. Because those are what you're going to want to use for this section as answers. This coordinate point is 1, 0. This is root 3 over 2 and 1/2. This is negative root 3 over 2 and 1/2. This is root 2 over 2 and root 2 over 2. This is negative root 2. Nope, sorry, switch those signs. This is positive. This is negative. Positive root 2 over 2 and negative root 2 over 2. This at the top is 1/2 and root 3 over 2. And at the bottom, it's 1/2 and negative root 3 over 2. This is 0, 1, and this is 0, negative 1. So almost all of that will be filled in on your unit circle when you get it. My advice is add on the negative angles. It'll make your life easier. So now the question is, if I'm giving you that the sine is 0, what angle is that? 0, right? What is your sine, the x or the y coordinate? The y coordinate, right? So I'm looking for where y is 0, which is at 0. So if I use that same logic, that arc sine of negative 1 is actually saying, give me the angle in which your y is negative 1. Where is that? Negative pi over 2. Sine negative 1 of negative root 3 over 2 is really just saying, give me the angle in which your y is negative root 3 over 2. Where's that? Negative pi over 3. Does everybody understand? So you're given the function, and your answer is the angle. Because if I look at all these angles, the only one that has a negative root 3 over 2 as a y is this one here. And so the angle that matches it is negative pi over 3. When you get your unit circle, my recommendation is add on those negative angles. Yep.
Will it ever ask for the angle but in degrees?
Ever? Sure. Within what we're doing? No. All right, so now think about it in terms of cosine. Same thing. We're going to take our cosine curve, which technically goes on forever, would fail my horizontal line test, and we're going to restrict it. But if we restrict cosine to the same thing as we restrict sine, what's true about all the x values from negative pi over 2 to positive pi over 2? They're all positive, and we need positive and negatives, right? So for cosine, you are restricted to 0 to pi. So first quadrant, second quadrant. For cosine, you don't have to touch your unit circle. It's already perfect. They're not adding on negative angles or anything like that. You just need to know that you're using first and second quadrant. Given that, this is the bank of which your questions are going to get pulled from without a calculator. The angles are going to go from 0 to pi, and your values are all the x values as you move around your unit circle in the first and second quadrant. So think about the same thing. Again, now think first and second quadrant, okay? This was your 1, 0. This is 0, 1. This is negative 1, 0. The over 6's are root 3 over 2, 1/2. The over 4's, root 2 over 2, root 2 over 2. The over 3's, 1/2 root 3 over 2. So where is cosine 1? At 0. Where is cosine positive root 2 over 2? Pi over 4. Where is cosine positive root 3 over 2? Pi over 6. Okay? If they were negative, then it would go into this quadrant and you'd pull from those angles. You still with me? So what do you think's coming next? Sine, cosine, tangent. Okay? Tangent is the same restriction as sine. So tangent goes negative pi over 2 to positive pi over 2. The only difference is that there's undefined spots on tangent, right? At negative pi over 2 and positive pi over 2, it's undefined, which is why we use that to find our asymptotes. So I use the same quadrants as sine. My angles are going to go from negative pi over 2 to positive pi over 2. And my values as I move around my unit circle are undefined, negative root 3, negative 1, negative root 3 over 3, 0, root 3 over 3, 1, root 3, and undefined. So my advice is when you get your unit circle, add on the negative angles and also add on your tangents because it's going to make your life a lot easier. This is just all three on the same spot, okay? So you don't have to pull, the only thing you have to understand the information here. So my sine is restricted from negative pi over 2 to positive pi over 2, cosine 0 to pi, tangent negative pi over 2 to positive pi over 2. So I'm going to add in what we did already for our sine curve because it's the same for tangent. Okay, my other recommendation is in addition to the negative angles, go back through your tangents and go back through your circle and add on your tangent, at least for one quadrant so that you know what it is. And the trick is, so at 0, it's 0 for tangent, okay? At over 6, it's root 3 over 3. At over 4, it's 1. At over 3, it's root 3. And then at the top, it'd be undefined. And then the bottom is the same, except it's negative. So the way I remember it is, think about an over 6. You need 2 3's to get 6, so it's root 3 over 3. And over 3, you only need 1 3 to get that over 3, and so it's root 3. So if you fill those out, these questions should take you like 10 seconds to do. What is the angle in which your tangent is positive root 3 over 3? Pi over 6. What's the angle if the tangent's negative 1? Negative pi over 4. What's the tangent if the angle if the tangent's negative root 3? Negative pi over 3. Okay? So the work is front loaded on this side. If you just add those points in on your unit circle, the questions themselves require no work. You with me so far? All right, so here's the easy part. The calculator does the work for you, okay? 2 catches here. There's not much partial credit that can give it, so be really careful, right? The other thing is all of these answers have been done in what? Radians. So you have to make sure your calculator's in radians, okay? So as soon as you see the sine negative 1 or the arc sine, you're going to put it in radians. The only time you use those buttons when it's in degrees is like your word problems, okay, if you're solving for the angle. So depending on your calculator, depends on how you type it in. If you have a graphing calculator, then you're going to do what's in the bottom. You're going to go second sine, and then 1 divided by 4. Hit enter, and you get 0.25268, which you're going to round. And then tangent, you would do tangent -1, negative 9.65, and you get negative 1.46753, which rounds. If you don't have, so you can use your graphing calculator. I would recommend it. You're getting comfortable with it. Use it, okay, on Tuesday. If you don't and you end up with a scientific one that doesn't store the letters when you hit the button, then you do the reverse. So you would do 1/4 and then second sine, or negative 9.65 and then second tangent. Good? Easy stuff, right? That's a free 5 points if you just make sure your calculator's in the right mode and you know how to round a number. So use the calculator to find the value rounded to 4 decimal places for each function. So tangent -1 of negative 5.2, negative 1.3808, cosine, second cosine, 0.2, 1.3694, and second sine, 0.8, 0.9273. Nope. Okay, the last thing is think about how we've utilized everything within this chapter. We've done it with unit circle, and we've also done it setting up what? Triangles, right? So if you get an inverse function that is not on your unit circle and you don't have your calculator, then the way that you would find it is setting up a right triangle. So some of these are helpful, like these are your inverses. If I'm trying to find the sine and I already have the sine of an angle and I'm doing sine -1 of that same angle, they will cancel out, okay? But in my opinion, I'm just going to go straight to the example because you need to know what to do with these, okay? So I'm going to go back to A because it's actually written wrong. Go straight to B because this is where your right triangle comes into play. And then I'll go back to A later. So B says, find the sine of something that has the cosine of 5/13. So you're working innermost parentheses out. So if I know the cosine of an angle is 5/13, there's only one way to get the actual angle, and that would be your inverse function on your calculator. If you don't have that, which you wouldn't on a question like this, then I have to use this information to set up a triangle. So I'm going to put cosine. I'm going to draw a triangle, put theta in the corner. Cosine is what? Two sides. Adjacent and hypotenuse. So this is 5 and this is 13, which tells you your missing side is 12. And then this is saying find the sine of that angle. So what's the sine of that same angle? 12/13. Don't overcomplicate it, right? It's easy stuff. So go innermost parentheses out. Innermost sets up your triangle, and then figure out what function you're looking for by the outside one.
So it's cosine -1 in the parentheses because you're finding the angle, but
right. So you'd be finding the sine of an angle, right? That's what normally goes there. And what the cosine -1 of 5/13 is give me the angle that has that. It's just that we're not finding the exact value. We're using that to set up the triangle. Yep. So go to C. It says the cosine, thank you. The cosine of tangent -1 of 2√3/3. So work inside out. The tangent is telling you opposite over adjacent is 2√3/3. Is that a triple? No, so I got to use the Pythagorean theorem. So 3 squared plus 2√3 squared is going to equal c squared. 9, 4 times 3, 12. C squared is 21, so c is the square root of 21. And now the outer thing is telling you find the cosine of that same angle. Cosine is adjacent over hypotenuse, or 3/√21, which is 3√21/21. And that reduces √21/7. Questions on that one? Okay, so then go back to A. This is actually the -1 should be on the outside and that should be gone from the inside. So this time it's the reverse. This time it's saying find the sine, so this should be gone, of 5 pi over 6 and then find the sine -1 of that. So what is the sine at 5 pi over 6? First of all, every over 6 has what coordinate point? Flip it. Root 3 over 2, 1/2, right? So what's the sine? 1/2. If it's 5 pi over 6, it's in the second quadrant. So does that half stay positive or is it negative? Positive. And then what's the sine -1 of 1/2? So where on my unit circle, think sine is now restricted, right? To second or fourth quadrant and first quadrant. Where would the sine be a positive 1/2? Pi over 6. So you got to work, this time we're flipping it. This time find the actual trig function first, whatever's inside the parentheses, and then find the inverse trig function last. Questions on anything 4-7?